So cool. Welcome everybody. Welcome to Becoming a Maker with Johnny 5 and Microcontrollers. It's going to be fun. I'm sorry if you've already done the Hello World before because there might be a lot of that. So I'm Matt Webb. I'm a front-end web developer at Blinker. Blinker is for an app for buying and selling used cars. If you're in the market or you just want to learn about Blinker and just different cars, totally download the app. It's really awesome. Now that all the Blinker people are in the back and they've already heard me do the spiel, I'm safe. So this talk's kind of like a 50-50. It's kind of to get you guys a little wound up and ready to be like start diving into being a maker. And it doesn't have to just be with microcontrol boards and stuff like that. I mean, makers are a lot of things. So enthusiasts, amateurs, DIYers, recyclers, reusers, crafters, I mean, it gets into a lot of different things. I mean, even just art or making dinner, like we're all makers. We're always asking, you know, can we do it? Can it be done? Not necessarily should we do it. That's, you know, kind of like Jurassic Park. It's like, can we do it? But the title's like Becoming a Maker, but like I said, we're all makers. So, I mean, how many people in here consider themselves a maker? How many people, yeah, I should have really went to that slide. How many people don't consider themselves makers? Come on, I saw like, there's not the right amount of hands. All right, for those who don't think themselves a maker, can you shout out why?
Creativity.
Creativity?
Anything I make.
And that, what?
He's a breaker. Yeah.
You had to be a breaker to become a maker, so you're halfway there.
All right.
All right, who here knows JavaScript better than C? Yeah, that's what I thought. Wait, who knows C? Nerds. Totally jealous, actually. All right, so who owns or has tinkered with Arduino, Raspberry Pi, Tesla, Esperanto, like one of those microcontrollers? Perfect. So at least half the room has been or one tinkered with them. Who here doesn't even know what a microcontrol board is? And I'm not going to judge you. None of us are. Come on, raise them higher. It's cool. It's fine. Perfect. Because I'll give you like the Wikipedia definition. So, kind of getting like into the maker space. Anyone seen Sandlot? Yeah, of course. Like Sandlot was great because they had a problem and all the kids came together and they started talking about like how do we get this, who the hell's Baby Ruth, baseball back? So like they made this thing out of what are those called? Tinker Toys? Is that what they're called? Kinects. Yeah. Rector set. Yes, those. You know, they took those and they tried to make a catapult out of it. You know, that was more on the tech side. But then they tried doing like a pulley system, and the kid almost got eaten by the dog. But I mean, even that's a maker thing. So this is a Sashimi Tabernacle Choir. If no one's seen this before, it's pretty amazing. So this guy took a bunch of those, you know, the sea bass that do the singing on the wall. So he took a bunch of those, as well as the lobster versions, and he has them all powered with Arduinos. And you probably can't see it very well, but on the tip there, they have one of the lobsters that's actually the composer. So they're all dancing and singing to the same tune, and it's the guy who put it together is like a nuclear physicist or something like that. And this was what he decided to do with his spare time. Has anyone heard of the MK2 Megabot? They challenged Japan to like a real mech war. I backed the Kickstarter for this. It's pretty awesome. So these guys, like, they built this thing. They built actually over several years. They built different pieces of it and started taking it to the maker fairs. And now they made it into a full-fledged robot that they can actually drive and fire, and you know, it's getting closer and closer to what I've been hoping for my entire life. So, 5-finger flight machine. I am not saying you should make something as dangerous as this, but if you're going to, do what they did, take a rubber hand or some rubber appendage and use that as your testing. Yeah, so just these are things you can make, and like with microcontroller boards and JavaScript. I mean, if you have to get super specific with decimals, it might not work so well with JavaScript, but maybe. So kind of like my maker background is, I did a Lego robot class in high school. That really got me interested, as well as like building computers. Took a soldering class, got interested in that. It's actually really easy to solder. I just don't recommend doing it like 2 in the morning after you've been drinking whiskey. You'll end up burning your fingers a few times. Made a few custom PC cases. And lately, now that I have a garage, I can actually do that. I started getting into woodworking, and that's been really cool because I started making, I made like a Colorado flag out of pallets over my fireplace, and now I'm tinkering around with the idea of taking like a Raspberry Pi and a lighting kit and doing something with that for no reason other than just to do it. And of course, tinkering around with Arduinos and JavaScript. So this is what I actually did recently, like started getting a wood shop together and making real physical things, and now I want to take technology and start to complement. So that's kind of the idea behind this, is like we can start making so many different things that take you totally away from your laptop and get you away and actually build something with your hand. Well, you still build websites and apps with your hands, I guess, but physically, not keyboard. So what we'll be covering today, what's a microcontroller board for the few people I didn't know, that's cool. What hardware basics should you learn? By the way, we are not actually going to really learn electrical engineering for web developers and stuff like that. I'll tell you where you can learn that because I didn't want to embarrass myself by telling you what I very well know. What is Johnny 5? Setting up Johnny 5 with Arduinos, Arduino demos. Setting up Johnny 5 with Tesla 2s, which is a little bit different than doing it with the Arduinos. And then a Tesla 2, it says demos, but it's a demo, but with multiples. So I'm not sure if that counts. We'll see. All right, so what is a microcontroller? It is a small computer, a single integrated circuit. It has inputs and outputs that are programmable. Think of it as the brains. It is your way of saying, hey, take this input, you have other places to output it, and you tell it what to do with that output. So it's the decision maker, or it handles whatever decisions you want it to make. So Arduino versus Tesla 2. So Arduinos are open source as an IDE, which my thoughts exactly. Yes. So we'll cover that. It's a simplified version of C++. It can run Node.js and Johnny 5, but you got to install what's called a firmware, which is, and how inappropriate to call it right now. So it handles using, it's called the Firmata protocol. So Arduinos don't actually have an OS on it, they handle like a firmware. So you install this firmware, it's written in C. And the Firmata protocol is actually just this, is the connection between my computer and the Arduino. And it takes that communication, and that's how it ends up working. And Johnny 5 is that interpreter to take your JavaScript and it knows how to communicate to your Arduino. So it can't run Node like on its own, like you can't plug a battery pack in it, install it, and let it go on its own. Like this is specifically great for prototyping on the cheap, which is what that last one is. So Tesla 2, also open source, which is great. It runs Linux. It runs Node.js right out of the box, so you don't even need Johnny 5. You can actually use Node right on its own, as well as their Node SDK, which is their Tesla 2 CLI. Pre-made configurations and shields. So for Arduinos, you can make shields, buy shields, and connect it directly to it, which is just simplified circuits that you can just plug right into it versus using Breadboard, which I'll explain what Breadboard is. Also perfect for rapid prototyping as well. But they're a little bit more expensive. Instead of an Arduino's like 10, 15 bucks, and it's like 40, 45 for like a Tesla. So shopping list, Arduinos, you've got like 22 different flavors, so it can be a little overwhelming. But if you're just getting started out, you'll want to get an Arduino Uno, which is pretty much the most common core, like everybody probably has one, and they're like 15 bucks, they're super cheap, so don't worry about breaking 6 of them. I put links in here, but you can get the Arduino Uno, or SparkFun has a breadboard, which is what I have up here. A breadboard is just, because it's open source, all they did was they took the Arduino Uno, simplified it, and manufactured it right here in Boulder. So that's pretty awesome. And they also have a SparkFun's Inventor Kit, which has like a breadboard, or actually it's pretty much this, and then a kit with sensors and pretty much anything you can think of to start tinkering with. But the great thing is it comes with a manual that will give you that little bit of electrical engineering for web developers. Tesla 2, you get one flavor, makes it pretty easy. Recommendation is you can buy just the Tesla 2 board. You can also buy the modules, which is their pretty much prefabricated shields. And then just like 2 weeks before I am giving this talk, I think it's called BootCup, who is the company Rick Waldron works for, who invented Johnny 5. He worked with SparkFun, and they actually just came out with an inventor's kit for Johnny 5 and Tesla 2, so you can actually buy that, and it will have that full kit for you, so you don't even have to think about what you need. So briefly, some hardware basics you should learn. Electronic primer, just understanding the basics of electrical engineering in terms of just knowing like what's the difference between analog and digital outputs. Do I need a 3 volt or 5 volt? Like I said, I'm not going to really explain what all that means, but there is pretty much like 10 simple things that you should learn that will take you like a half an hour to learn, and once you learn it, you can be very dangerous in this realm, which is fun. But also learning like the little components of like what does a resistor do? What does a diode do? What does a motor do? Just once you start learning those basics, you can start piecing together the different parts, and really helps you expand your creativity. For those who say creativity is really hard. So how to use a breadboard? Breadboard is actually, it's one of these. I got this on camera. So this is a breadboard. It basically allows you to start rapidly prototyping without having the need to solder. Makes it so much easier. So once you start learning how to use a breadboard, just how the configuration works, which is fairly simple, that'll help you tremendously and not have to burn yourself constantly. Soldering is fun. In my experience, desoldering really sucks. Everyone else seems to have a different view on that besides me. I hate desoldering. So I quadruple check every time before I solder something. Multimeter. Multimeters are really nifty tools. It'll start helping you really debug where your connections are losing power, or just making sure you have the correct circuit from one component to the other. So this is where Johnny 5 comes in. Hello. So it's an open source JavaScript program framework for robotics. It's created by Rick Waldron. For those who don't know who Rick Waldron is, he's also like on the ECMAScript board, so he also helps define the future of JavaScript, so he kind of knows what he's talking about. It's maintained by a really awesome community. They're very forgiving on how new you are. And it seems like there's a lot of hardware engineers in there that you don't really have to search very hard for an answer. Like I said, the community is super duper nice. So why Johnny 5? Like we already did that poll, everyone knows JavaScript a lot better than C. You don't have to compile anything. You just run node blah and it just goes and does its thing. Also, we get the REPL in there, which helps a lot for debugging.
Why not something that's generally more a little closer to the processor, like Go, or just curious, like what, other than familiarity, what does JavaScript provide?
So, well, Johnny 5 is written in JavaScript, so
Sure. Right.
that's automatically the go-to there. I'm a front developer, I don't know Go.
Okay.
So
No, that's a good point.
that immediately is it's a lot easier for me to be dangerous in JavaScript than something else I'm not familiar with. Because you can take things like Python and there are things just like Johnny 5 that are in Ruby or Python. But there's plenty of them out there. So actually, I think there is one in Go. Wouldn't surprise me.
I think that answers my question. I was curious. I was curious as to
This next one will actually probably answer it. Atwood's Law. Anything that can be done in JavaScript probably will be done in JavaScript, so just accept it.
No, that's it.
And also because why not? So you're jumping the gun. So this is kind of like one of the things I want to bring up, and unfortunately, I was hinging a lot on this support. So there's like a Nintendo DS touchscreen that I was wanting to use with Johnny 5. And I just asked anyone had they done it. Rick Waldron hopped in. He's like, "So I purchased one. It's on its way. I'll let you know when I come up with a solution." It's like, sweet. He came up with a solution like 1 week after I had tried giving a talk like this before. So, whoops. Now I tried using that same code last night, and Johnny 5 had made a breaking change that kept that from working. So I wasn't sure which version of Johnny 5 was working. So unfortunately, we can't actually do that presentation. So this is the fun of getting started with an Arduino. So once you get your Uno or Breadboard, whatever one you end up doing, plugging it in, you got to download the Arduino Ide. You connect your Arduino to your computer. You're going to launch the Arduino Ide. And you're going to File, Examples, Formata, Standard Formata, which is, again, that connection, your communication between your laptop and the Arduino. So you select your board type, which is really important because if you're switching between different types of Arduinos, it is going to try and install it a different way. So make sure you pick the correct board type from the settings menu. And if it doesn't know which port it's on, you'll have to find that too, which all through the settings menu, it's pretty straightforward. You upload it, and once you're done uploading that formatware to your Arduino, close Arduino IDE and kill it with fire. Sorry, I want to watch that a little bit longer. It's great. Now, once you've actually done that, you then can just run Johnny 5 constantly on that all day long, unless you've changed whatever firmware you've loaded onto Arduino. So, because everyone says they know JavaScript better, I'm going to already assume step 1 is already done. Everyone's already had Node.js installed. Make your new project forward, do an npm init, follow those prompts so it builds the package JSON so you don't have to actually write it. And then npm install, save Johnny 5, and you're ready to go. Which is, right now, we're going to do demos. So the hello world of the hardware world, which is just a blinking LED. And how many people already knew that? I feel great right now. All right, so the code's really easy. So we're including Johnny 5. We're creating a new instance of the board, which you can set different types of boards, but by default, it's just already understanding it's an Arduino. So then on board ready, it's going to figure out what's the LED. So the LED, it says 11, which I'll show on here. So there's a pin connection here for the LED, which is pin 11. And then also that part down there, we're injecting into the REPL, the node REPL of LEDs, so we can actually tinker with the hardware so we don't have to keep redoing the node. And then the LED blink. So this is the pin I was talking about. So this is the ground. And then this is pin 11, which is where we were telling it where the LED is actually located. This is in case it didn't work. That's what should happen. So we're already tunneled down into my, can everyone see that? Should I make it bigger? How big? Is that good? Well, that's not good. There we go. So we should be able to just say, set LED as the JS file. So we just say node LED. It would help if I was in the correct directory. So right now what it's doing is it's looking for the board. And it's looking really hard. And all else fails, we'll log it back in again. Hey, there we go. I got confused. Oh, hey, you know, it blinks. So now we have the REPL. So we can actually hit the LED instance and we can actually say, you know what, just turn it off. Wide. Okay, so apparently I couldn't turn it off for some reason. But we'll wait 10 seconds and see if it'll actually, oh, there it goes. It turned off after 10 seconds. I might have been a little dramatic on that time. How about that? We'll turn it to every second. Alright, so now we've, just through the REPL, we've changed it so it's just every second, it's blinking. So it's really awesome to be able to inject things directly in your REPL so you can just keep tinkering with it. It's like, you know, it's your console with, you know, your web inspector tools. Same idea. So now we're going to get super advanced. We're going to make it trigger with a button. I know it's crazy. So the same idea. We're telling it it's on pin 11. We're creating a new instance of a button, which is actually connected through pin 2. So that's what that number represents. For no reason, I decided to put it in the, inject it into the REPL again. So anytime we press down, it's actually going to adjust the LED brightness to 255, which I think is about half power. I think. And then if we hold down on it every half second, it's going to just keep turning it on and off again. And when back up, we'll stop it and we'll turn the brightness back down. Actually, I take it back. 255 is the max brightness. So now we should be able to just do node. Oh, that's node button.js. All right, so there we go. So right here, it's kind of, sorry, this is really hard to do. So right here is a button, and that button should trigger the LED. All right. So if we hold it, it should continue blinking until we let go, and then it'll turn back off. So that is Hello World plus 2. Times 2. Almost. Cool. So this is the setup using the breadboard. So we have our button. We have a resistor. It's just so we're not supplying it way too much power. And it's triggered here into the second pin. And again, in case it didn't work. So now the one I stepped on before everyone got here, let's see if this one actually still works. Alright, so this one is actually an Arduino Uno. Yeah, that twitched, that's a good sign. So this is a pan tilt. So the pan tilt, we have 2 servo motors. One's for the tilting and one's for panning. If that makes sense. Then we have this. Why am I getting? Sorry, I keep getting notifications. We have a little joystick here. Just looks like something off your PS3. Again, a Arduino Uno and a breadboard. So what we're saying in here, the same mumbo jumbo you've seen before, but what we're saying here is we have a range. These are the varies of degrees, so we're just saying like between 0 and 180 degrees because it's not a continuous servo, meaning it can't move 360 degrees. We're giving it a range so it doesn't accidentally snap its own neck. So then the pan servo is on pin 9. The tilt servo is on pin 10. The joystick is on pins A0 and A1. The A stands for analog. And then the frequency, we're just saying like every 100 milliseconds to listen to the changes of joystick. Then we're going to set the tilt and pan to center, just so it's, in case you were using it before, it'll recenter it. And then on the joystick, as it changes the position, we're translating that into degrees to the pan and the tilt. So this is the setup for that. It looks more crazy than it looks. I didn't have time to make a new schematic, but this one, this is actually like if you were to send extra power to it, but we don't have that in this setup because we're not using the battery to power it. Again, in case it didn't work. Let's hope it works. So let's see if joystick still works after stepping on it. So let's see if we can actually do this on extras. Alright. So this is a camera on the end of it, but I didn't have time to hook up the camera, but that would have been pretty sweet. So as I move the joystick is translating movements. And then it just kind of twitches. This is so much fun. Amazing. So I can't believe that still worked after I literally stepped on it. So that's just some of the stuff, like to kind of get your little primer, your feet wet into just what you can do with an Arduino, which is a lot of fun and super cheap. But now we're going to move along to Teslas. So I actually probably should go back to the camera. So each one of these Teslas actually has one of these modules connected to it. Like this one is a climate module, so it will do humidity and temperature. This is an ambient sensor, which does light and sound. So you can plug these in like this, and you have to do absolutely nothing except plug them in and then get the node module that they've already programmed and everything for you, and you can just immediately start using it. Or with Johnny 5, you can start plugging into the pins and actually doing robotics work. So there's a lot of things you can do with this.
Is it limited to one at a time?
Two modules?
One module?
No, I can actually, so I did this because I had to. So I did to be fancy. Now you can take both of those modules and you can make them communicate with each other. So if it's getting too loud, you could tell it to flicker some lights or something, or it's too hot in here, have it turn on LED, which is what's going to happen. Sorry, there is setup that is required with all of these. There's no simple way to do it. So the great thing with these Teslas is I do not have to have it plugged in here. I just told it to push my node app to it. So I'm going to plug these in now because they do have a boot time because it's an actual Linux environment. So those are going to boot for a little bit. But what's great with Tesla is there's not a whole lot of setup. Like you don't have to go through the Formata stuff. It's already loaded with Node right on it. So after you have Node.js installed on your computer, you just got to do the npm install for Tesla 2 CLI. Make a new project for it. You do T2 init, which is the same thing as npm init, but it just does a few extra things for Tesla. And then you do npm install Johnny 5, which you actually don't even need for the Teslas, but we're just doing it because it was part of the title of the talk. And then the Tesla IO. Tesla IO is actually specific for Tesla's running Johnny 5. And it's needed just so it knows the inputs and outputs to translate to Johnny 5. Still like my favorite gift ever. No. Oh, wow, it's doing that. So we have one more thing to plug in. I have enough things. All right, is everyone prepared to have their minds blown? That's the spirit. Thanks for that. All right, so this is just an Arduino Uno. And the setup is super simple. We just have these different LEDs, but these LEDs have certain purposes. They're going to be our status notifications. So we have the climate sensor, which does humidity and temperature, and then we have the other end, an ambient sensor, and that ambient sensor does light and sound. Now, the only thing we need to do, at least for that Arduino, is we just need to run the LED stats. All right, so that's connected. So the red light is on. Awesome. So, all these are, so the two Teslas are connected to a Firebase database right now. So as you can tell, it's like about 39% humidity in here. Almost 85 degrees in here. So I didn't plan for that, so this red light's going to constantly be on because I said if it's 82 degrees or higher, always be on, so, whoops. Sorry, I had it. There we go. So for the ambient light sensor, we'll keep the numbers up here for now, I'll blow them up. So you can see the light sensor is reading at 0.03. So now the green light is on, and because of my booming voice, the blue light keeps turning on. There it goes. And then for humidity, which is the yellow light, a very humid breath. So all that's talking, so we have two Teslas that are connected to my phone's Wi-Fi that are updating a Firebase database, and then the Arduino Uno is connected to my laptop, which has Wi-Fi to my phone, which reads to the Firebase database. So they're all connected. They're the same Firebase database. So the cool thing about that is if you have multiple Teslas, where you can have a Tesla talking to a Raspberry Pi, they can run, as long as they have their own power source, they can run a node application standalone. So you can have whatever it is that you're wanting to control from your living room to your bedroom based on the environment in there. You can have it communicating through the same database. So kind of do that same demo so you can see a little bit more. So the blue light will go off. I didn't even have to snap. So anytime it reaches whatever threshold I told it, it's going to light up the blue light. Like I said, it's too hot in here, so it's always going to be red. The yellow light will go off when it's too humid. And then the green light will go off when it's too bright in here.
Where do you buy your sensors?
These modules,
Yeah.
the modules are actually available through Tesla's website. So they have, yeah, I know, I was pretty disappointed when SparkFun didn't carry any modules yet. So these are the modules that they already have baked into them. They have the accelerometer, Bluetooth, RFID, ambient, they have tons of them. But then they also have USB modules, so you can plug in, like, I actually probably could plug in this USB camera, but I didn't have time to tinker with that just yet.
So you go directly to Tesla to buy them? Or Tesla to buy them?
Yeah, so the Tesla device actually has, so a Tesla device actually has 2 USB ports and an Ethernet port as well. But they also have Wi-Fi built into them, so it's pretty awesome that you don't have to put shields in just for those. Yes. So just to give you a little, like, this is kind of how this LED stats are working. So we're including Firebase. Ignore my configuration, don't copy my configuration. It's on the GitHub repo. So after we initialize the Firebase database, on board ready, we're just setting the different pins for whatever stats we want those lights to represent. The variable for database, that's just connecting to that Firebase database. That sounds repetitive. So the reference is just saying these are the different parts in my JavaScript object for that database. So we have temp, humidity, light, and sound. And just depending on the thresholds, like for temperature I said 82, which I dramatically underestimated for in here. So if it's above 82 degrees, turn on that status light. Like I said, it will shut off now. Humidity, if it's more than 70% humidity. Now the light and sound, I didn't do my due diligence and figure out what those numbers actually represented. I just figured out what my baseline was. And then just put greater than that.
The on value, can you change how frequently that event fires? Or how often does it fire?
So the on value is actually Firebase's on value check. So these are constantly keeping, so on the database reference of light, on value, it's just constantly watching for value change. Now, whether or not you can change how often it looks for it, I would assume so, but I haven't actually tinkered too much in Firebase. So that's just for the LED stats. For Tesla, it's just the climate.js. So we're including Tesla, the climate-SI7020, super specific. That's for the climate library that's supplied through Tesla. Tesla I/O, that is specifically for Johnny 5 so it can understand which board it needs to create. So that's what I was saying when you're creating a new board, if you don't supply what I/O it's supposed to be, it's just going to default it to an Android, or sorry, an Arduino. So with this one, we're saying IO, new Tesla IO. Now they also have the same thing for Raspberry Pi. So if you were to do a Raspberry Pi, you would say IO is a new Raspberry Pi IO. Raspberry. Again, same configuration. Ignore, you can copy and paste it later. So we're telling it, the climate library, we're telling it to use Tesla's port A, which is this first port up here. And the other one, of course, is going to be
C.
so close. B. Where's it? B. Correct. So then once the climate sensor is ready, we're going to say cool. Set immediately to start doing the loop. And that loop will just look at the climate, we'll read the temperature, we'll read the humidity, and then where it says temperature ref and humidity ref, that's the refs we set up top for the different database refs on Firebase. So then they'll set that humidity and temperature to those endpoints. And ambient, same thing. You know, it is pretty much almost exactly the same thing. When the ambient's ready, when the board's ready, we'll set those variables for the ambient library, the Firebase endpoints, and then we'll just iterate over watching the ambient for light and sound, and also updating that to the Firebase database. Do you need to take it? It's awesome. So, kind of run out of time. Sorry, I didn't realize it lasted so long. So where does this leave us? I mean, you now have the power to have just ideas. So people are struggling with creativity. Home automation, still working on my Nerf turret. If anyone else wants to, work on that, it's fun. Make node bots, home arcades, home brewing. I know a few people have been doing this with home brewing. It's not easier to do it this way. They just want to see it can be done. 3D printers, art installations, just use your imagination. Really just building it and ideas will come. I mean, just making, just putting some LEDs into a breadboard, you'll be surprised what kind of weird and stupid ideas you might come up with that are just fun to play with. So, I don't know why I put that in there, it's just fun to warn him. So there are tons and tons of suppliers, but the main people that you're going to want to get them from is SparkFun, which are right here in Boulder, so if you're super impatient, they actually now have a storefront. So you can actually go there, play with some of their demos, you can get some ideas, and end up walking out or spending a couple $100 without even thinking about it. I've never done that. Adafruit also, they make great products and they're reasonably priced. So both of those, highly recommend. If you're in a pinch for doing a talk on it, Micro Center, a little bit more expensive. Their selection is a little bit finicky, but I mean they carry a few things, including NodeBots. Sometimes they have SparkFun products, including their inventor's kit. They've had those a few times. Radio Shack, yes, Radio Shack is still a thing. They actually still have NodeBot, like starter kits and starter kits from Make Magazine. So all those, they still carry. So because his hand was up first, questions.
Yeah.